Lesson 4A, Graphs of Higher Degree Polynomials. So we have this this blue line going across diagonal here, and I'm putting these arrowheads on them because they are absolutely important. These arrowheads that I'm putting on it. So this is a line. I hope you understand that diagonal line. Yes. So the equation of this line is what is it? Anybody? What's the equation of this line? Okay, I'm going to answer my own question. Is y equal to x? Y equal to x is the equation of that line. And that's called a linear function. Alright, so let's add to it. Here's the next concept you need to understand. As I go to the left, it's going to be called the left end behavior. This is going to be called left end behavior. What's the left end behavior? What do I even mean by left end behavior? What I'm asking is as I keep going to the left, the inputs are going to be right here and right here and right here. So as I keep going to the left, what is the graph doing? What is this diagonal line doing? It's going what? It's going down, 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 down forever. And if we can make this screen bigger, infinite, that thing would be going down into the ground, way down there, down, down, down there. And if I go over there to the office, it's going to be like, I don't know how many meters inside of the earth. So if you have a good imagination, because that's what it is, that if you can see that this thing is going to go forever down as I go to the left hand behavior is going to be negative what? Don't everybody rush to say this. What do you guys think that is? A sideways 8 is called an infinity sign. This is negative infinity. So the outputs will go to negative infinity. I think that's how you spell behavior, okay? Right end behavior. As I keep going to the right, to the right, to the right, the outputs are going, where are the outputs? What's the graph doing as I keep going to the right? What is the graph doing? It's going what? Up, up, like sideways, but it's going up, 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 like it's going to go to positive infinity. I can put a plus here in front of infinity, but we already know it's an infinity. So that is the big idea here. Y equal to x is the equation here. Left hand behavior, as I keep going to the left, the graph is going negative. Right hand behavior is going positive infinity. The next function we studied for like a month was this function here. Which function is that one, anybody? What's the equation of that thing right there? Anybody? What's the equation of this? So anyways, I will answer my own question. And the equation for this thing here is called y equals x squared. It's a parabola. So what's the left hand behavior? We're going to do left hand behavior. I put left hand behavior. And right hand behavior. That's a lot of writing. You know what? Let's we already know what this says, left hand behavior, and let's kind of let's kind of just abbreviate it. LEB for left-hand behavior. Yes or no? Is that okay? We already know what we're talking about. Just doing too much. Well, you guys just write too much and like, let's call it LEB or something. Left-hand behavior. All right. As I keep going to the left, what is the graph doing? What is the graph? Let me put the arrowheads on them. What is the graph doing? As I keep going to the left, it's going up positive infinity. So the left-hand behavior, which I still gonna have write the whole thing down, left-hand behavior, but you could go ahead and write it like this, left-hand behavior. I don't know. All right, just to speed it up if you want to. Left-hand behavior is positive infinity, and what is the right-hand behavior? Positive infinity? Yes? Basically, this is how it works. Let me tell you how polynomials work. Look. Would you agree that this is straight? Yes or no? It's like a line straight, no? Now, look what I'm going to do. Hopefully it doesn't break because it's broken before. Hopefully none of this shot is going to my eye. Maybe it will put you be careful too, my break and go. What does this look like right here? What does this look like? It looks like a U, doesn't it? Yes or no? And if I grab it, which I'm not going to do, and then twist it again down here, and it's always going to be smooth. So it's just going to go like sideways. It's going to go like this, and I'm just going to twist it. So you go like this. Instead of going up, I'm just twisting it down. That's really what's happening here. And that's going to be the next function, which, what do you think if you see a pattern here? Y equals x to the 1, y equals x to the second. Which one do you think that one's going to be? That's a good question. What is it? X to the So what's the left-hand behavior? Negativo infinito. Right-hand behavior? Positive infinity. It really is not that difficult. See, when it comes to that, either you get it or don't get it. And some people are like, I don't get it. What? I don't know how to explain. It's just going to negative infinity. And it's going up positive infinity on the right. Okay, we gotta get going now. This is a actually, we do have a lot of time. It's not a Monday. It's a Tuesday, and we got what, like 100 minutes? We got a whole bunch of time. Oh, okay, we do have. I was like, all right, let's move on. Let's continue. You guys had enough time for that one? Let's go. Polynomials. So polynomials. The first one was a line, which was y equal to x. What's the general equation of a line? You're 60 years old, and there's something that you do remember from algebra. What's that equation you're going to remember? Y equals mx plus the general equation of a line is called y equals mx plus b. That's a general equation. When we had y equal to x, that's the parent function. And what does y equals mx plus b look like on a graph? It looks like a line. The next equation is y equal to x squared, which is the standard form of y equals x squared. What's the standard form of a quadratic? Yeah, don't everybody rush and say y equals ax squared plus bx plus c. Quadratic equation is the standard form of a quadratic is y equals ax squared plus bx plus c. And this looks like a parabola. Should be like a u, not a v. It's a u. The next equation is going to be of what degree? What equation degree is going to be a what? Third degree, which we said it was y equals x cubed. But the general equation of it is going to be for a cubic function. It's called cubic. Cubic function is going to be y equals what? A is going to be there. X, but it's not going to be 2. It's going to be what? 3. Then what happened? What's after A? What letter goes after A? B, X what? Squared plus what letters after B? C, X1 plus what? D. That is a cubic function. And what do cubic functions look like? They kind of look like a sideways S. If you want it, it's kind of like a sideways S. I kind of stopped in the PowerPoint, but if I wanted to continue on, it's going to be called a quartic. Something like this. I don't know. Quartic. That's what, a fourth degree. I could kind of stop already, but I'll just add it. Y equals what? What letter goes first? A, x to the fourth plus what letter? B, x to the third plus what? Cx squared plus dx plus, what's after d? I think you get the point. A quintic is going to go y equals what? Ax to the fifth. I'm going to stop. You get it or no? You all get it? I'm going to stop. So we have a linear, quadratic, cubic, quartic, cubic. No, what the heck? Cubic, quartic, and then I don't even know what they're called. All right, whatever. All right. Is there another way to name these polynomials? There's another way to name these polynomials. You have a what? Don't you have a first name, last name? Yes or no? You have a first name and a last name. And that's the way we're going to categorize polynomials. The first name will be its highest degree. So for a linear function, what is the highest degree? The highest degree is 1. For a quadratic, not quartic, for a quadratic, what's the highest degree? What is the highest degree? There's only one person here. What's the highest degree for a cubic? What's the highest degree for a cubic? What's the highest degree for a quartic? So naming polynomials, the first name would be its highest degree. So you get to choose between what? First degree, second degree, third degree. Not choose, but choose the correct one. No? On and on and on and on. Its last name would be the number of terms in that polynomial. So how many terms are there here in this linear function? How many terms? In between pluses and minuses, the number of terms. 1 term, 2 terms. How many terms are there for this quadratic? How many terms? 1, 2, 3 possible terms. How many terms can we have for a cubic? Possible? 1, 2, 3, 4. But you don't have to have all 4 of them, or all 3 of them, or all 2 of them. You can just have 1 of them. You can have 2 of them. You can have 3 of them. You can have, and we'll do examples right in a minute. So the last name is the number of terms. What do you think is going to be called a one term? It's going to, I'm going to give it to you so you get a monomial. Monomial is a one term. What do you think we're going to call 2 terms? Have you heard of Yes. Binomial? Binomial, yes, it's binomial. What do you think is going to be 3 terms? Trinomial. You're smart. trinomial. And what is going to be for 4? I don't even know either. I don't know what it quadrinomial. Well, I don't know. Stop. That's enough. We just call it polynomial. I don't even know what it is. Anything beyond 3, just call it polynomial. All right, let me give you an example. You're gonna give it a name. Okay, here we go. I'm gonna give you an example, and then you guys gonna do it. All right, example. Give this polynomial a name. Y equals. That's a good one. Let's go. Give it a name. Give it a name. Go around, write it down. Go ahead and write it down on your paper somewhere and give it a name. Somebody over there saying, it looks like a Jose. We'll go with that. Anyways, give it a name. Anybody? Let's go. Give it a name. Its first name is going to be the highest power. First name is going to be the highest degree of the polynomial. The highest power of this. What is the highest power of this polynomial? It is going to be a third degree. It's going to be its first name. How many terms are there? 1 term, 2 terms, 3 terms. That's going to be its last name, is the number of terms. It's a third degree trinomial. Let's do another one. One more example. Let's do one more example. One more example. Y equals. There. That's another polynomial. Let's go. Let's give it a name. Second degree binomial. Yes? Second degree binomial? Okay. So I hope that you get the idea here. You get to choose from here for the first name, from all this, and then here for its last name. Let's go. Okay, let's continue. Let's go. Write this down. We got it. We got to get going here. Classifying polynomials. Decide whether the function is a polynomial function. If so, write it in standard form. Give the name of the polynomial. Draw a rough sketch. Use Desmos if you need to. And then describe the end behavior. What does f of x equal to 2 look like? Yeah, let's get going. Look, a lot of you guys just sitting around. I gotta get going with this. You guys gotta keep up. So there are a lot of things we gotta do here. Decide whether the function is a polynomial. Yes, this is a polynomial. F of x equal to 2 is a constant. It is a polynomial. Write it in standard form. It is already in standard form. Give the name of the polynomial. This is a constant function. Let me kind of give you the name of it. Has one name, just like very famous soccer players and like that. You know, like it's just they have one name, or like very famous artists. Who knows Prince? Anybody know Prince? He has one name, Prince. Anyways, this function, let's just call it a constant function. Constant. It's really a 0th degree monomial if you really wanted to. What does it look like on the graph? It's a horizontal line. This is what it looks like. And for this one, don't worry too much about left-hand behavior, right-hand behavior. I don't want to talk about that in this one. Maybe it's gonna mess you up a little bit. So go ahead, let's copy that down and move on to the next. So this is a constant function and it is horizontal. I do have it. What's the left-hand behavior? Let me see how, like, I said that this graph looks like this, no? What's the left-hand behavior? Siempre va a ser 2. It will always be 2. No matter how far I go, the y value will always be 2. No matter how far I go. I can go to the library, and if this thing keeps going over there, the y value will always be 2. So the left-hand behavior is 2. The right-hand behavior, I go to the right, it will always be 2 because the y value is always 2. It doesn't go, it's not increasing, it's not going up, or it's not going down, there's nothing. Whereas, let's go with number 2. H of x equals 7x cubed. Is this a polynomial? And yes, it is a polynomial, yes. Write it in standard form. It is already in standard form. Give the name of the polynomial. So it is a polynomial. Let's give it a name. It's just one person in this class. And I'm telling you, this, take responsibility. I'm telling you, you know I see people, and I see some people, not a lot, on their phone or watching something right now. And look, don't be asking me about how to get my grade up later on. No, none of that. Don't be like, I remember you. I have really good memory. I'm treating you like an adult, so you have free will here. And you get, anyways, 30. So there's gonna be somebody said it here in this class. You said third-degree monomial. You don't even know how easy this lesson is. Third-degree monomial. It's not even math. It's naming third-degree monomial. What else are we gonna do? Draw a rough sketch of it. Yeah, I guess a third degree looks like this. Look, a third degree looks like a sideways S. Something like this. I don't know. Look like something like that. A third degree looks something like that. So what's the left-hand behavior? You can now kind of quickly get the left-hand behavior. What's the left-hand behavior? Well, I guess you did it. As I go to the left, what is the graph doing? Negative infinity. As I go to the right-hand behavior is going to be, as I go to the right, the graph is going positive infinity. Let's go. Keep going. Let's keep going here. All right. Problem number 3. Same questions. What were those questions? Is this a polynomial? And of course, yes, it is a polynomial. Yes, it is. Write it in standard form. What does it mean by writing it in standard form? Standard form is that it goes from high power to low power. Yes, this is in standard form. What else are we going to do? Give it a name? Everybody give it a name. It is the highest power is second degree trinomial. Second degree trinomial. Draw a rough sketch of it. What do second degrees look like? Don't they look like a parabola? Don't they look like a U? I don't know. I'm just gonna draw a rough sketch. I'm just gonna do looks like that. It's positive, no? What's the left-hand behavior? Positive infinity, yes. What's the right-hand behavior? Positive infinity. Yes? Good? Next, problem number 4. Is this a polynomial? And the answer is yes, it is. Everybody, what's the name? Give it a name. Third degree polynomial. Yes, polynomial because we got 4 terms. I don't know how, what do you call that? I just call it a polynomial. So it's a third degree polynomial. And third degrees look like a sideways S. As long as this is positive, it's going to look something like this. And that helps me do left-hand behavior. So what is the left-hand behavior? What's left-hand behavior? Negative infinity. Right-hand behavior? Positive infinity. Yes? Yes. You can put a plus in front of the infinity, but I don't know, I guess. But you don't have to, because if it doesn't have a plus, it's automatically assume it's positive. 5. Okay, now we're getting to something that is a little kind of messed up here. Is this a polynomial? Yes, it is a polynomial. Is it in standard form? And the answer is no. Why is it not in standard form? Because it has to go from high power to low power. So what needs to go in the front? 3x squared. And what goes after 3x squared? Negative 2x and then plus 3. So now, yes, this is in standard form. And now we can give it a name. What's going to be its name? Second degree trinomial. Second degree trinomial. So now this second degree trinomial, what is the left-hand behavior? Oh, I need to draw it. Okay, I guess you... Isn't this a parabola? Isn't it positive parabola? What's the left-hand behavior? Positive infinity. What's the right-hand behavior? Number 6. Is this a polynomial? Yes, it is a polynomial. Is it in standard form? It is not in standard form. So let's put it in standard form. What needs to go first? X cubed, and then what goes in the back? Minus 2x. Now we have it in standard form. Let's give it a name. What is its name? Third degree binomial. What is the left-hand behavior? Left-hand behavior is no. What do third degrees look like again? Let me do a rough sketch again. That's why I said do a rough sketch. Third degrees look like a sideways S. Third degrees look like a sideways S. What is the left-hand behavior? Negative infinity. What's the right-hand behavior? Positive infinity. Seven. Seven. Yes, got it. All right, 7. Let's go. Number 7. Is this a polynomial? Yes, it is a polynomial. Is it in standard form? No, it's not in standard form. So it is a polynomial. It's going to be in standard form. It's going to be f of x equals what? 3x to the 4th. What else? Plus 3. Give it a name. 4th degree trinomial. 4th degree trinomial. Left-hand behavior. All right. So you're like, how does this look like? What do 4th degrees look like? 4th degrees look like, look. First, a linear function looks like this. A quadratic, you twist it, looks like this. Twist the left side again, looks like this. Twist the left one again, this is what it looks like. It looks like a W. All you're doing is just twisting the left. So first degree here, second, third, fourth. Okay, what's the left-hand behavior of this? What's the left-hand behavior? Positive infinity. What's the right-hand behavior? Positive infinity. Eight. Is this a polynomial? Man, this is so repetitive. Yes, it is a polynomial. It is not in standard form. F of x equals what to be in standard form? What is to be in the front? 3x to the 5th. Then after that, it's going to be what? Negative 2x cubed plus 3. Give it a name. 5th degree trinomial. Okay. What's the left? This one again. Let me see. Erase. 5th degree trinomial. And again, you're gonna be like, what does this look like? Well, didn't we have 4th degree look like a W? Yes or no? Yes. What am I gonna do to the left? I'm gonna twist it, no? So then it's gonna go something like this. Yes. So left-hand behavior is gonna be what? Negative infinity and then positive infinity. Moving on, let's go number 9. We're almost done here. We got 9 and 10 and we're done. Let's go number 9, copy it down. Is this a polynomial? Is this a polynomial, yes or no? Is this, yes, it is a polynomial. Yes, it is. As long as it has x squared, x4, hey, it has a root 3 here in the front, it's fine. It's okay to have a root 3. Weird, but it does have, it's okay. So, yes, it is a polynomial. So now let's put it in order from high power to low power. So it's going to be f of x equals what? Let's put it in standard form. What is it going to be? Oh, give it a name? Is it, we got to give it a name first? It's not a second degree. No, we got to put it in order, no? Yeah, we got to put it in order first. So it's going to be what? F of x equals what?
5x.
Then what? It's going to be what? What's the name? Fourth degree trinomial. Fourth degree trinomial? What's the left-hand behavior? What do fourth degrees look like? What do fourth degrees look like? Don't they look like a W? Didn't we talk about that? Look like a W. So what's the left-hand behavior? Right-hand behavior? Last problem, I think. Yep. Is this a polynomial?
Yes.
And the answer is no. Why is it a no? You cannot have a negative power. It has to go from high power to low power all the way to 0. So once you get a negative power, it's not a polynomial. Not a polynomial because of the negative power.